Okay, so welcome to the demonstration video for the CSE 4202 blockchain project for a voting system in Guyana. So to run this application or to get a feel of what was done, the first thing you need to do is go to this GitHub repository, which the link has been included in the submitted document with the source code. And to go to this link and retrieve the source code. Once you've done that, you're going to need to install some dependencies, some external dependencies, namely the Node package manager, which will allow you to install some other things that will be needed to run the project. You're going to install Truffle, which is something used to build, deploy, and test smart contracts in dealing with blockchain technology. And then you're going to install Ganache, which is an in-memory blockchain for the purpose of testing. We'll also need an extension by the name of MetaMask, which will be used to manage the interconnection between the browser and the blockchain, as well as your built blockchain application. So once all of that is done and you download the project, you'll need to open a CMD within the project directory, and you're going to need to type these commands in order to install the required dependencies. Then you're going to need to start Ganache. So Ganache is your in-memory blockchain. This is the in-memory blockchain. It looks something like this. So just a quick walkthrough of what is going on here. So this is the public address of the first test account on the blockchain. This allows you to reveal the private key. You will need this to actually authenticate yourself to the MetaMask. More on that in a bit. And this allows you to see your transaction count, and this is the balance of Ether within your account. So Ether is needed to conduct any transaction on the Ethereum blockchain. So this is fake Ether, but it allows us to test the application that was built. So once you have Ganache running, you're going to want to compile and deploy the election smart contract, which is basically creating a new instance of the election. You're going to use this command to do that. And once the election has been deployed, you're going to need to set up your MetaMask. So MetaMask is a Chrome extension that allows you to interact with your in-memory blockchain as well as the global blockchain. This is what it looks like. So there are some options here where you can select the network that you want to interact on. You have the main Ethereum network where there's real Ether and there's some other test networks. For our purposes, we'll be using a custom RPC, and you would declare whenever you click on custom RPC, it'll give you a window where you can declare the name and the location of your custom RPC. So this location here is actually the URL within Ganache, and so that's how you connect your application to the Ganache in-memory blockchain. Once it has been connected, you also need to add a configuration that was mentioned in the README, whereby you need to set a connection by going to settings, into connections, and just add in this extra local host so that the application can know that it's interacting on your local machine. Because for some reason this local link to the actual blockchain is not sufficient, so this additional argument is needed. So once you've got all that set up, you're going to go ahead and deploy the application, which I will do now. So to that, we type npm run dev. So what this does is it launches a development server that allows you to interact in real time with your local application. So this is when the application loads. So the reason you would have seen just this part of the table being there before this actually showed up, this part of the table doesn't actually exist on the blockchain because currently there's no support for storing images or graphics on the blockchain is only text-based. So this is actually being solved from the front end and not the blockchain itself. So that therefore means that it will be rendered faster than what is actually in the blockchain. But nevertheless, it achieves the concept. So this is how the voting interface will look. And so you have your different candidates here. Right now the election has just started. So everyone has 0 votes. You can select from the dropdown which party you want. And there's a secure pin that will be issued to each individual voter. This will be hard coded in the backend upon deployment of the contract. So, and this is your public address on the blockchain. So before you can actually vote, you must first import an account from the blockchain through MetaMask. So when you go over to Ganache, this is just for demonstration, we'll see that this account hasn't been used yet. So we're going to copy the private key. Once it has been copied, you can go back over to the MetaMask. Click here, import account, supply the private key, import, and you will see now we have account here. So we're going to try to vote with this. So the way you load that account is you just hit the reload button. So if we look at the public blockchain address here, it ends in D0B1. So D0B1, if we look on the blockchain, this was the account that we just imported, D0B1, so it's reflective of this actual account on the Ganache blockchain. So now we have that. The next thing you need is a PIN, because the one blockchain account is not enough to authenticate you to the voting process. So we're going to vote for the dog party, and we're going to use the account 2083 and hit the vote button. Now MetaMask will ask for a confirmation, and this will allow you to spend some Ether to vote. So once you've voted, you'll be taken to this page, the election results page, and for the election results page, you can now view the results after you have voted. So everything was 0 initially. When you hit view results, you'll see that the dog party now has 1 vote. Once this is done, this is basically the end of the voting process for you. You can't do anything else on this specific blockchain account. And neither can you vote with the same pin again. So for demonstration, we're going to try to load another blockchain account. Of course, we'll get back the voting page now because that's the way the application is set to behave. But if we try to use 2083 again, let's just vote for the vote party and we hit vote, we'll get up to this point, but then I'll throw an exception whereby it'll say that there's a transaction error. So the pin is actually tied to blockchain, meaning that it will actually block you even though you have a different blockchain account. You can only go to that pin once, and in that way you ensure that only one pin is issued to one user so they can vote only once. Right? So you can repeat this process for the other 3 accounts, but then once those are exhausted, since there are only 3 pins in the backend, you need to redeploy the contract to actually vote again. Okay, so I'd like to thank you for listening to our demonstration of the application, and we do hope that whoever is running this application actually gets it to run, but basically you've seen what the application